right? What's up, guys? So we're gonna do unusual minesweeper. This is a cool problem. I don't play the actual game Minesweeper, but um, maybe I should. I don't know. I'm not really into that many games. That's kind of boring. But this question is cool. So basically, we have a bunch of mines, right? And they have sort of what you call a blast radius, sort of. And this blast radius it blasts in like a plus sign. For example, this mine, its blast radius is 2, and the way it blasts is like in a plus sign, as you can obviously tell. And the idea is that like you have a K, which is the blast radius of all those mines, and you know that it starts to like explode when its lifetime has been expended. So for each mine you get a lifetime, and so when the lifetime is being expended, it blows up. But Polycarp, here's what makes it interesting. Polycarp can choose to explode a mine before its lifetime, and and now if he can, then what's the minimum number of seconds all mines can get detonated? So um the first thing is to realize is that this is a graph question in disguise. I don't think it's really too hard to see that. Like, if you think about it like this, right? If we're exploding stuff and we like, if one might, so it's really not that hard because like the test case really kind of gives it away. That's a graph problem because like in this example, if you explode 0 0, then it explodes 0 1 and then 1 0 and then their explosions explode 1 1, right? So in a way these mines are connected, right? I'm hinting towards it, like it's a connected component. So the idea is that we can think of this problem as just a bunch of connected components, right? So for example, if look, let me just screenshot this sort of frick. So if you zoom in on this guy, what the heck, okay, whatever, I won't bother. I guess we Okay, so I wanted to just zoom in on this guy, but it's taken a while. But the idea is that like this thing over here is effectively just one node, or it's one mine, right? Because exploding any one of these mines will explode everything. So you can just think of this as basically just one mine, or just one connected component. And so then the idea is, and if this is just one mine, then the lifetime of this mine is just the minimum lifetime of any one of these mines, because once the first node explodes in this group, then everything will explode. So what you can do is you can basically just like group these in, and you can also solve this with DSU. I think I yeah, that's more, yeah, whatever, by the DFS. But you can basically find the components, and we'll talk about how to do that in the code. But basically the question is actually kind of simple. You just find the components, right? um the connected components, and then once you find the connected components, you can assign each component a time. And then the idea is that like you always want to explode the mines that are going to take forever to explode, so you sort the components by their lifetime. And then once you sort the components by their lifetime, it's very straightforward with what you do after that. So the thing is, how do you get the components, right? How do you get these connected components? Well, it's just actually just DFS. Like you need to create the edges, I would say. So treat each thing as like a node, and then you need to create the edges, right? So you need to say, okay, 0 0 can reach two nodes. It can reach 0 1 and 0 1 and 1 0, and this is because k is equal to 1. So for each node, you can just like for each node as a parent, then its children are basically all the nodes that are reachable from this blast radius. So just connect an edge between those two nodes. And I'm just going to talk about the code now because this is more of a coding problem. Like the actual logic is really simple. This is more just coding. So basically, I think my implementation is not the most like cleanest implementation, but like whatever, it works, right? But um, I'm gonna have. Don't worry about this. It's just defined over here. Doesn't need to. But I have a node class, which is maybe not. Maybe you don't need it. It's probably like not. But like, yeah, I don't know. My implementation skills are not good. But like, yeah, node class takes an X, Y, and lifetime and the ID of the. Because for each node you want an ID. You basically the ID compresses the entire node into an integer, right? And then boolean on X. Well, okay, this thing is just for like sorting and stuff. So what I'm going to do is that like I use compare to. So basically, if like let's say because what I'm going to do, let me explain this, right? What I'm going to do is that for each x value, right, in the problem, I'm going to, so let's say I have an x value of 6, then I'll add all the nodes that I'll make a list of all the nodes that have an x value of 6. If I have an x value of like 10, I'll put all the nodes, I'll make an array, I will map that to an array list of all the nodes that have an x value of 10. I'll do the same thing for y, because this will allow me, because I noticed that like I'm only going to connect an edge between two nodes if it's on the same vertical line or the same horizontal line. Therefore, I want to group it in a way where I can get, okay, these are all the nodes on the same vertical line, and these are all the nodes on the same horizontal line. If you can do that, then you can just see like if it's reachable and stuff. It's really easy, right? And so to do that, you can just take in the input and set the map up. But what this compare to thing is doing is that, okay, if you have all the nodes that have the same x value, right? So they are on the same vertical line, right? Let's say these are just all the, let's say these are all the mines, right? Well, then when you're iterating through them, you want to iterate them in either two ways. You want to go from least to greatest in terms of y values, or least to or greatest to least in terms of y value, or least to greatest in terms of y value. You want to go through them in sorted order, right? So if it's on a vertical line, you want to sort them by y. So that's what this is doing, is that we're saying that, okay, if this node is on a vertical line, then sort it by y. If it's on a horizontal line, so like this, if it's on a horizontal line, then sort it by x, right? So then sort it by x. If it's not on, so if it, to know if it's on a horizontal line, then we can just check if it's not on a vertical line. So that's why this ternary statement's doing. And then yeah, that's basically what it is. So we'll get that, and then we'll go through the map for each like x value. We'll sort the nodes there that correspond to there, and we'll sort it, and that's what it's going to do over here. And then I'll create a graph, an adjacency list, and basically I'll create the edges, right? It's basically gonna fill this adjacency list. And create edges is very simple, right? For a map, it can be x or y. I have a boolean on x to tell me if it's x or y. I'll just say, okay, I'll go through each value in that map, get the nodes, and then it's really easy. If it's on a vertical line, we'll just check if the y values, the difference of the y values is within k. If the difference of the y values is within k, then uh yeah, oh then you can just simply just you can simply just add the mines. Also, I should clarify. I sort of didn't clarify this. Okay, so if this mine can reach, like if this mine can reach this guy and also this guy, you don't really need to add an edge between this guy and this guy, because you're gonna DFS and just find the connected component. So I guess I didn't really specify that pretty well, because I did say that like we're gonna create edges between all the nodes that are reachable from one node. You don't actually need to do that. You just need to do the closest one, because at the end of the day, it's just gonna be all connected components. Because if this node can reach this node, then surely this node's gonna reach this node, and because this node can reach this node, then it'll also be able to implicitly reach that node when you DFS. So you only need to create edges so that's sort of one nuance in the code. You only need to create an edge on the closest one, right? So this is what it's going to do, is that you take the difference, right? And if the closest one is just the one next to it, right? Obviously. And if it's within k, you could just add an edge, and you can add it bidirectionally. And then if it's on a vertical line, you look at the x values, right? So if it was like, you look at the x values and just check if it's within k, and you can add it. So this basically just creates the edges. Right, once the edges are created, then we'll just do standard DFS to find the components. So the DFS is literally just standard DFS. It's literally just DFS. It's like the very basic DFS. And then once you find the components, you'll get, so each component will have a lifetime, and that's just basically the minimum lifetime of all the components you visit in the DFS. And then you'll just say component. You can basically compress the components, because for a component, you only care about its lifetime. You don't care about anything else. I don't even care about what nodes are in there. I just care that, okay, there's some component that has this lifetime. So you have like an array list of components which are compressed to just their lifetimes, and you just add them. Once you add them, you can sort them in a reverse order. Then you can have a timer. You can remove the largest lifetime at zero, and you can iterate through all the components. And basically, if the component has already exploded, then just break out because we're sorting it, right? So if we know that this component has already exploded, then since the other components will visit after in this loop, well, their time is going to be obviously less than that this, and if this is already exploded, then those will already explode. So you just break out. But if it isn't, just keep moving the timer and then print out the answer. So yeah, that is the problem. It is pretty simple. What did I do wrong, right? If you look at my first, it literally looks the same thing, right? Um, yeah, it literally looks the same thing, bro. Like this is my first one. Literally the same thing, dude. It's literally the same. It looks like you know what? It's this. It's this. The only difference between this and my first code is literally just this. It's literally this. Cause I'm being very dumb. Just very dumb stuff. It was just very stupid stuff. But yeah, just have to be careful. I guess I should have just done like if on it. Okay, whatever. But yeah, it's literally just that those letters that like could have just saved me so much time. But yeah, I know I need to debug more effectively. Like I debugged everything else but that, but it's fine. Anyways, that's it. So cool. Happy New Year's. Yeah.